Okay, so past paper question to do with moment. Okay, a light wooden beam balanced at its center has a small cube placed 12 centimeters away from the pivot. This is exactly balanced by a small magnet of mass 60 grams when it's placed 10 centimeters away from the pivot. So, first question. How can you tell that the mass of the cube is less than the mass of the magnet? If you see that the magnet is 10 centimeters away, the cube has to be 12 centimeters away in order to balance. So you need to say the cube is further away from the pivot in order to balance the magnet. Okay, mention both the cube and the magnet. Next question. Show that the mass of the cube is 50 grams. This is for 2 marks. Now, this is a slightly complicated way of doing it. What it's asking you to do is work out the moment on this side. Moment equals force times distance. And then we're going to work out the mass on this side by comparing the two moments. So, the moment on the magnet side is 60 times 10, so we're looking at 600. On this side, we need to find out what we times the 12 by to make it equal to 600. So we can divide 600 by 12 and we get an answer of 50 grams. Does that sound reasonable? 50 is less than 60. That's why it needs to be further away. So we're happy with that. Okay. Next one. Really simple one. My dog vomits and it actually tells you what it wants you to calculate, density. So density is equal to mass divided by volume. And then we're going to put that information into the next question to score 2 marks. So density equals the mass, which is 50, divided by 12.5, which we have just been given. So we end up with an answer of 50 divided by 12.5, which gives us 4. So we would write 4, and then we would write the units in here. It was mass divided by volume, so that's grams divided by centimeters cubed. So the answer is grams per centimeter cubed. Just be wary of this. People get confused when it says unit. People start thinking, is that, do I put my decimal there or something like that? It just means what is it measured in, units of measure. Okay. Moving on to the next page, you can see we're introducing a bit of magnetism here as well. They like doing this at Common Entrance. They need to test you across the whole syllabus, so they can combine 2 topics in one. They will do. So another small magnet is brought close to the one on the beam, as shown in the diagram below. This causes the beam to tip down on the right, so it's tipping down on this side. Okay. Mark the diagram with the letter N to show the north-seeking pole of the magnet on the beam. Again, no dots, people tend to leave this out. So this is going to push down, so we're looking for the N to be here. Okay, so the N would be at the top of the magnet on the beam. What causes the beam to move down on the right? So why is this moving down here? 2 marks, so we need to mention repulsion. You can talk about, like poles repel, and you can say that that force pushes down the beam. Without adding anything to the cube, what must be done to restore the balance? Okay, so it's pushing down on this side, so in order to balance it, you're going to have to move the cube further this way. You can't add any more weight to it, it says that. So you would, bearing in mind we're getting 2 marks, so you can't just say move it. You would say move it away from the pivot, or move it to the left so that it balances. Next question. Kathy is playing with some blocks. She has 1 block made of iron. This measures 1 by 2 by 2, so this is the small block. She also has several blocks of wood. Each one measures 1 by 6 by 6. Each of these wooden blocks has the same mass as the iron block. So this block and that block have the same mass. First question, which material is denser, iron or wood? Well, this one has the same mass, but it's much more tightly packed. So this one is going to have the highest density. You probably know that yourself. Iron is much denser than wood. It gives you the 2 options. It's 1 mark, so if you don't know, guess. Kathy is going to place the iron block and one wooden block on some flour in a tray, each one resting on its largest face. So they're going to lie down this way and that way. State and explain which block is likely to sink further into the flour, and this is given a massive 4 marks. State and explain. Okay, so you need to say which one's going to go the lowest, and then you have to explain why. So the iron will sink the furthest. It's got the same mass as the wood, but the area is far less. So that area on the bottom is far less. We know, and I put it in here, pressure equals force divided by area. So because we've reduced the area, the pressure on the iron bar is much higher. Final question. Kathy builds a tower by placing the wooden blocks on top of each other. How many wooden blocks will make up the tower when it sinks as far as the flour as the iron block? So what they're saying is, how many of these big blocks will it have to stack up in order to go the same distance as this one? So what you're asking to do is compare basically the area along the bottom here in contact with the flour. So this one is obviously 2 by 2. This one is 6 by 6. So 2 by 2, 2 times 2 will give you 4. 6 times 6 will give you 36. So if you divide 36 by 4, you get an answer of 9. Okay, so the answer here is 9 blocks, but you have to refer to the calculation of the base area in order to get the marks for that. Okay, thank you.